All right, so we are gonna move on over to section 5.4 today. I'm gonna go ahead and throw out there that the microphone on this laptop is not the greatest, so I'm gonna do my best to talk loud and right into the microphone, but it may cut in and out. So I apologize for that. We are gonna spend a second day on this tomorrow, so if it doesn't quite sink in too great, no worries. We can go over it tomorrow whenever hopefully I'm back. So 5.4 is talking about medians and altitudes. So we've talked about a bunch of different ways that you can create a segment in a triangle. And so two new ones today. So the first one is going to be the median of a triangle. So median is a word that we've heard before. So if we talk about a data set of numbers, like test scores, the median is going to be that middle value, which means half of the values are above the median, half of the values are below. So it cuts the values in half. So the median basically does just that, but on a triangle. So in a way, you could call it a bisector. It's going to cut a side in half. We've talked about perpendicular bisectors, and a median can be a perpendicular bisector, but is not necessarily a perpendicular bisector. It's going to be a segment whose endpoints are a vertex and the midpoint of an opposite side. So for example, one of the medians here in this picture could be segment JD because it goes from a vertex D to the midpoint of the other side, which is J, and I know that because it shows me that it's marked, that those two segments that it creates are the same. Another median here could be segment FG. Once again, it goes from a vertex to the midpoint of the opposite side. And then we also have segment EH, which is also the other median. Now, these medians are always going to be concurrent, which remember from last week, concurrent means they're going to cross at one point. And this point of concurrency, so this point M right here, is going to be called the centroid of the triangle. So we're going to review all of these different points of concurrency at the end, but the points of concurrency for the median are called the centroid. Now, I'm gonna be honest with you, I'm kind of struggling with this theorem a little bit. It's the concurrency of the medians theorem. So we've talked about the other properties that the concurrency of these segments create. But the current concurrency of the medians is a little bit more difficult, at least for me to understand. So this is the medians of a triangle are concurrent at a point. Okay, so that's the centroid right here. So point C right here, we know that. We know they're concurrent. Now, they're going to be concurrent at a point that is going to be 2/3 the distance from each vertex to the midpoint of the opposite side. Okay, so the median, so if we were to talk specifically, let's talk about this median here, GE. Okay, so the median is segment GE. Okay, so the median is going to be concurrent at this point C. So that point C is 2/3 the distance from the centroid to the vertex, okay? So what it means is that segment CE, so that distance CE right there is going to be 2/3 of the entire median, so segment GE, okay? So if I were to look at another median, so let's pick out this median FH. Okay, so if I were to go from the vertex to the centroid, so FC, so the vertex to the centroid, that distance is going to be 2/3 of the entire median FH. Okay, let's do the last one since we are already this far. The last median is DJ. So in that median, if you go from the vertex to the centroid, so DC, that is going to be 1/3 the entire median, which is going to be DJ. Now, I think what's tricky is that you just have to keep separate which side you are going to here. So, for example, sometimes we're not given the distance from the vertex to the centroid. Sometimes maybe I'm given the distance from from the midpoint to the centroid, okay? So here's the thing. If I'm given this distance, think about this. If this distance is 2/3 the entire distance, what's left right here is going to be 1/3 of that entire distance. So let's backtrack this a little bit. So let's say we're given JC or CJ right here. That is the distance from the midpoint to the centroid, okay? This distance right here is 2/3 of the whole distance. So that smaller segment is going to be 1/3 of the entire distance. Okay, so we'll do a lot of practice with that later, but that one, like I said, it's going to be at least harder for me to kind of nail down. All right, so let's look at one of those. So in this diagram at the right, XA, so this distance right here, okay, that's going to be measure 8. I want to know what is the distance of XB. Okay, so remember what I have here is I have the distance from a vertex to the centroid, okay? If you have the distance from the vertex to the centroid, okay, that distance, that XA, is going to be 2/3 the entire median, which is XB. Okay, well, here's the thing. I know that XA is 8. So 8 is 2/3 the distance of XB. So this is really just solving a nice little equation. So to get rid of 2/3 so I can solve for XB, we could multiply by 3/2 to get rid of that. Notice the 2's cancel out, the 3's cancel out. So we would end up with 12. XB is going to be 12. So we'll do a couple more of those there. Okay, so the other segment that we're going to talk about in a triangle is what's called altitude. So altitude, I mean, this is a word that we've definitely heard before. We could talk about the altitude of a plane, the altitude of a mountain or of a hill. Altitude is just kind of height, okay? So the altitude of a triangle is going to be the perpendicular segment from a vertex to the line containing the opposite side. So it basically means you're going to start at a vertex of the triangle and you're going to go straight down to the opposite side, okay? So for example, if I look at this triangle here, okay, if I start at this vertex here, okay, and if I were to travel straight down, it would have to be a perpendicular line because remember the distance from a point to a line is the perpendicular segment, okay? So if you go from the vertex straight down to the other side, that's the altitude. Now here's the thing, since you have 3 vertices, you're going to have 3 altitudes. These points are always going to be concurrent. This point of concurrency is going to be called the orthocenter. The orthocenter of the triangle. Okay, so we have Theorem 5.9, which luckily is not going to be as confusing as Theorem 5.8. It talks about the concurrency of the altitudes, and it just says that the lines that contain the altitudes, they're concurrent. There's no special relationship here, no equidistance from the vertices or the sides or 2/3 the distance. We just know that they're going to be concurrent. Okay, so to kind of review, we've talked about different segments that we can have in triangles. So the first segment is we talked about perpendicular bisectors. So if you take the perpendicular bisector of each side, they are going to cross at a point. That point is going to be called the circumcenter. Okay, and then we have angle bisectors, which are going to be the segments that cut the angles in half. That point is going to be called the incenter. The 2 ones today, the centroid is the intersection of all of the medians, which remember the medians are going to cut the sides in half, go from the midpoint to a vertex. And then the last one's going to be the orthocenter, which is going to be all of the altitudes. So that point of concurrency for all of the altitudes. Okay, so let's get to practicing some of this. This is going to get glued into page, I believe it is, page 71 of your notebook. So go ahead and get that glued in. I'm behind a few pages here, but page 71, this is section 5.4, and we are talking about medians and altitudes. Medians and altitudes. So make sure you get your table of contents filled out, get that glued into page 71, and we'll look at some examples here. So we are going to have some fun drawings. It's going to be kind of important that you guys try to draw them as similar to mine as you can. So we're going to use the same drawing for the first three examples. So we'll take our time drawing this. So over here to the right, let's draw triangle ABC. Once again, it doesn't have to look exactly like mine, but it will help if it looks similar. So we'll call this bottom left vertex A, the top vertex B, and that right vertex C. And what we're going to do is we are going to draw the medians of all of these sides. So let's draw a segment AN. So that's going to go from vertex A over to segment BC. So we'll call that to point N. This is going to be a median. So I know that those two segments are congruent. Okay, let's draw the median from B. So let's go BM. So that segment's going to be M. Once again, it is a median, so I know that those two segments are congruent. And then let's draw the last one, which is going to be CL, okay, which we also know that those are congruent. And let's call that center point there K. All right, so we have our triangle drawn. Now it tells me in triangle ABC, K is the centroid, which means this is going to be the intersection of all those medians. So let's start here. Let's say if AK equals 6. Let's find KN and AN. Find KN and AN. Okay, so it tells me AK, so this distance here, okay, that's going to be 6. Remember, what I have here is I have AN is the median, okay? The distance that they've given me is the distance from the vertex to the centroid. So remember, that distance from the vertex, AK, to the centroid is going to be 2/3 the entire median, which is AN. So I can kind of set up this equation that I have here. Now here's the thing, I know what AK is. AK is 6. So if I plug that in, I would get 6 equals 2/3 AN. And then I can solve for AN. So we're going to multiply by the reciprocal. So I'd multiply both sides by 3/2. And we should get AN equals 9. Okay, so what I have here is I know that AN, the entire thing is 9. So the other thing that they want me to find is I want to find KN. Now, here's the thing. There's a couple ways you could do this. I mean, probably the simplest way, if you know the whole entire thing is 9, if that much of it is 6, well, the rest of it, that KN, I mean, it'd have to be 3, right? If the whole thing is 9, I know part of it is 6. Yeah, the rest of it's going to be 3. That's probably the easiest way to do it. Let's just keep it simple. Let's just do that. Okay, let's try another one. Number 2 says if BM equals 12, we want to find BK. Let me type correctly here. We want to find BK and KM. Now, this time they give me BM. This time they give me that entire median. They tell me that the whole median is 12, and then we want to find the two separate parts. So remember, the distance from the vertex, which in this median is B, to the centroid, that BK, that distance is 2/3 the length of the entire median, which is BM. So this one's going to be a little bit easier to find because I know what BM is. They tell me BM is 12. So to find BK, I'm just going to take 2/3 of 12. And 2/3 of 12 should be 8. So BK is going to be 8. Now what we can do for the next part is the same thing we did on the last one. I know if the whole thing is 12, well, if that much is 8, well, 12 minus 8, the rest of it would have to be 4. And let's just do one more of those. So number 3 says if LK equals 10, we want to find KC and LC. All right, so let's see what information we're given here. So they tell me LK. This distance right here is 10. Now, here's where you have to be careful. So we are wanting to find the other two parts. We're wanting to find this distance here and then the distance of the whole thing. I think probably the easiest thing to do first is going to find the distance of the whole thing. Now remember, this distance here from C, from the vertex to the centroid, that is 2/3 of the whole length. Well, here's the thing. If that's 2/3 of the whole length, this is 1/3 of the whole length. So LK is 1/3 of LC, which is the median, the whole thing. Well, I know LK is 10, so 10 is 1/3 of LC, just like we did before, multiplied by the reciprocal, which is just going to be 3. So LC, the entire median, is going to be 30. Well, and if the whole thing is 30, LK is 10, that means KC is going to be 30 minus 10, or 20. Okay, I would say, in my opinion, I think that's probably the most confusing thing we do today. Just remember that this distance here from the vertex to the centroid, that's the 2/3 distance. That's 2/3 of the whole thing. Okay, so the next we're going to kind of apply some of the information that we've learned so far. So we're going to look at triangle XYZ. We're going to look at the red segment, and we're going to decide if it's a median or if it's an altitude, or maybe it's neither. So number 4, let's draw an obtuse triangle. We'll, of course, call it triangle XYZ. And my red segment is going to go from the vertex X down to this segment here. And then I'm going to call those two segments congruent. So we have a couple options. So it says, is the red segment a median, an altitude, or neither? Now, if it's a median, it's going to go from a vertex to the opposite side, and it's going to cut that opposite side in half, which, if you notice, that's exactly what's happening here. X is the vertex. X, to whatever this segment would be called, cuts this in half. This is going to be a median. Okay, number 5. Let's draw a triangle. It looks like this. We'll call it triangle XYZ again. Okay, now this time, my red segment, let's put it over here, okay? And we'll put that at a right angle, like this. Okay, now, if it's a median, okay, first of all, it's going to have to come from a vertex. And notice that this segment doesn't start at X, Y, or Z, so it cannot be a median. Also notice if it was a median, it would have to cut one of the sides in half, and it doesn't do that either. Now, let's check and see if it's an altitude. Now, I mean, in altitude too, though, if you remember from what we talked about just briefly over here, an altitude has to come from, has to go from a vertex, and it has to go straight to the opposite side. And I mean, we already said that this doesn't come from a vertex. So here's the thing. If it doesn't come from a vertex, it's not going to be a median or an altitude, okay? If this was an altitude, it would have to come from Y and have to come straight down, and it doesn't do that. So this is going to be neither. Okay, and then number 6, let's do this kind of sideways triangle like this. X, Y, Z. And then the red segment's actually going to be this segment YZ, and we're going to call that a right angle. Okay, now, once again, if it was a median, it'd have to come from a vertex, which, I mean, it does kind of come from the vertex X or Y and Z, so it does come from a vertex, but it'd have to cut a side in half, and it doesn't do that. Okay, if it's an altitude, it would have to start at a vertex, which we said, okay, it does start at the vertex Y and Z, but it would have to come straight down and form a perpendicular line. And if you notice, that's exactly what's happening. I know it's on its side, but it is starting at point Z, and it's going straight down to this segment XY. So this is going to be an altitude. Okay, last one. We're going to draw a fun little picture down here. Okay, so let's start by drawing triangle A, B, C. Once again, it doesn't have to look exactly like mine, but the more you can make it look like mine, the better off the examples will end up. So let's call this down here A, this top one B, and then here C. All right, so let's start. Let's draw a segment from A to the opposite side. We'll draw it to point Y. Okay, we're going to do two things. We're going to call this a perpendicular line, and I'm going to make BY and YC congruent lines. Okay, let's draw a segment from C to the opposite side, and we'll call that to point X. And I'm going to say AX and XB are congruent. Where these meet, let's call that point M. And then the last thing, let's draw a segment from B down to this bottom here. We'll call that a perpendicular line, and we'll call that point Z. And then this point right here where those two lines intersect, let's call that point N. Okay, so we're going to do 4 things here. Okay, first thing, let's name the centroid of triangle ABC, the centroid. Now remember, the centroid is the point of concurrency for the medians. So what I need to find is I need to find the medians. So the segments that start at a vertex and cut the other side in half. And I do have 2 of them. Notice that there's technically 3 medians, but I already know that they are going to be concurrent, so I don't have to have all 3. AY, that's going to be a median because notice it cuts that segment in half. And then CX, that's also a median because it cuts that in half. So the point where those 2 lines intersect is point M. So that's going to be my centroid. Okay, number 8, let's name the orthocenter of triangle ABC. Remember the orthocenter, okay? The orthocenter is going to be the point where the point of concurrency for the altitudes. Remember the altitudes, they need to start from a vertex and go straight down to the opposite side. So the first obvious one here would be BZ, right? It goes from B straight down, forming a perpendicular line. And then the other one, this one goes from A straight down to that segment once again, forms a perpendicular line. So where these points meet is going to be point N. Okay, number 9, let's name a median of triangle ABC. Now I have 2 options for medians here. You could name either AY. Remember we said that it cut that segment in half, or you could name CX. You wouldn't have to name both of them. You could if you want, but segment AY and segment CX are both going to be medians. And then lastly, let's name an altitude of triangle ABC. So same idea, right? Except it's going to be either, right, the height, that B, Z, or we said it could also be segment AY, that one right there.